Welcome to episode 8 of the PM Blend. Mark Powell, Joe Finksler. Joe?
Hi, Mark.
Nice shirt, Joe.
Hey, I see you went for the wild and loud again, so I'm proud of you.
Well, you dared me, and here we go.
And you took that challenge.
I like your shirt. I might have had that same shirt on in a previous episode
one or two back. Yeah. I think I had it on before too.
Right. Here in episode 8, we're going to talk about some of the advancements in PM manufacturing and how that's impacted our industry. And we're happy today to have two of our automation engineers with us, Luke Crawford, Andy Recker. Welcome, guys. Thank you for joining us.
Thank you.
Yeah. Joe, what do you think? Should we jump into
this pool?
Some advancements in automation and such. Yeah. All right. Let's get started. Luke, how about we start with you? And how has automation been integrated into the powdered metal manufacturing process?
Well, in the past 25 years that I've been involved, we've just added some automation to replace some handling operations in the molding area, in this inserting operation sizing area. But basically, we just kind of look for areas where we have a person doing a task that's basically picking up, putting down, and we'll replace that person with automation. Like in molding, instead of having a person raking parts off of a machine, we'll actually have a robot placed there to palletize those parts and move them on instead of having a person stand there. So it's just things like that.
Okay. Yeah. All right. Andy, what are some of the key benefits of integrating these automation systems that Luke has talked about in the powder metal production?
Just to add on to Luke's automation spiel there was the pick and place. As you guys know, some of our parts are intricate, have real fine detail. In the green state, they're very, very fragile. So Luke and I, together, we do a lot of 3D printing. We'll 3D print custom end-of-arm tool fingers for the robots to go in. And when they structurally grab that part, it has all sides wrapped or it's around it to set it down. Our material handling is huge for us. If we can eliminate the cracks there, or if we can eliminate any issues we may have getting it from the press to the carbon tray or a cardboard tray or to the cart, that's huge. In a lot of our day-to-day is teaching robots, 3D printing, end-of-arm tooling, for material handling.
Now, you guys have both been in this for a while, but 25 years ago, it would have been a challenge to try to get a press to do what you're trying to do, because you still have to tie to that press. I mean, you would have been into some type of a sensor on a cam, right, to try to pick a position.
We still have some like that. So, yeah.
So how much is the computerization of the equipment and the control systems on the presses helped you from that aspect?
Oh, tremendously. Now we're into doing an inspection with a camera. So, as far as we're not replacing the person inspecting that part, but that camera can do it 5 times faster. Mm-hmm. So speed is essential to our automating something, whether it be an inspection, whether it be material handling. As far as some of our robots we have robots palletizing, as he said, putting them, the consistency of having it on that tray. So we're loading carbon trays on the ovens, and all the parts are consistently placed. So we know how. And now we're tied into our ERP system, our Plex system. We know how many are on that cart. We know how many are on that tray. We know how many went through that oven. So the traceability is huge, and that's all automated. Whereas 25 years ago, that wouldn't have been, you would have to
would have been a lot more challenging to try to get there.
10 on there and 10, yeah. So, yeah, it would have been a challenge. We've tried to bridge that gap.
Yeah, and for our customers, that traceability in their quality departments, I mean, that's huge. That's something that's really important to them. And of course, the speeds you talked about, that leads to what cost savings oftentimes for not only for us, but that in turn saves our customers money too. So all that seems to be really important. So can you share some specific automation technologies used in powder metal manufacturing?
Well, I mean, we can start in the green handling. I mean, obviously we use a lot of robots, 6-axis, 5-axis. We use pick and place units. We use conveyor systems. All these things used to increase the reliability of our material handling. If a defect's going to occur, it's going to occur in the molding department. So anything we can do to reduce human contact of those parts, is going to effectively give us a better product at the end of the line. So, I mean, we've implemented robotics. A lot of, 20 years ago, there was no robots, and now, we have a robot on probably 50% of our presses, we have robots on there. And like Andy said, we have cameras. We have cameras that we can place at those machines to, actually look for defects in the green state. We actually have it on a machine right now. So, there's a number of things that we've added. I'm probably forgetting, but as Andy said, with the 3D printing, it's given us the ability to really customize grippers. So we can take a part that we really want to make sure we get a good hold of that part and not damage it. Mm-hmm. And we can actually go in with a robot with a custom-made gripper, and we can grab that part, flip it, place it without having to worry about damage, especially when you get into like the gears and intricate components like that. We really have got the ability to really customize that process.
We've also gone through our molding department and some of our old school pneumatic style accumulating tables or chutes. We've taken them and kind of revamped them. They've made improvements in sensor technology, with laser sensors, photo eyes. And the operators will load 3 or 4 trays, and the parts will come down and it'll go through, and when that tray gets filled up, pneumatics will open a valve, close a valve, open a gate, close a gate, and we'll load trays that way. I mean, that's old school automation, but we've been able to improve that. We've been able to tune that in pretty well.
I think it's given us the ability to have a safer operation. So we, with having a robot going in and grabbing parts, there's less opportunity for injuries. So, ergonomically speaking, we've always, or that mindset, how can we implement a process that's going to be easier for the operator? Not eliminate the operator, but how can we make their job easier? Mm-hmm. So we from that standpoint,
and safer.
Right. We've been able to implement a lot of different processes that not just part quality, but quality of for the employee too. So.
Okay. Yeah. And I have seen, we have a lot of automation back in our secondary department too. Mm-hmm. So we've got, pretty much a full machine shop here in secondary department. And, Andy, talk about what's back there.
Our secondary department is new within the last 5 years. Mm-hmm. So you're correct. It is new. And as that's all machine tending. So you're taking parts and loading it, unloading it, loading it, unloading. That is a perfect application for a robot.
Yeah.
Now we have to go through with our group, our automation group, and figure out how are we going to load that part. So we have to come to a nest, to a central point, to a location. Maybe we add a couple sensors to pick that part up, make some custom grippers, figure out how to. Now we have to interface with that machine to control-wise to start it. Stop it if there's a problem, if that robot would fall out or if there was an error, I have to stop that. Mm-hmm. Stop that machine, stop that operation. That has helped us maintain our consistency with
one of our biggest success stories back there is we brought a process in from another facility that was being maintained by 3 operators, and we've got that down to 1 operator now with implementing a robot, a camera, a palletizing system. Mm-hmm. So we're able to really make that process way more.
And in that particular case, the major advantage you have it's not the number of operators. It's the fact that those operators aren't going to do everything the same way all the time. These robots and machines and inspection systems that they put in place, they're checking all of the parts. They're handling all the parts in the same manner. Mm-hmm. So you don't have the variations and the potential dinging, banging, impingements that you might run into if you had an operator on it. They stepped away for 5 seconds and came back to handle it. Now you've got parts backing up. Well, now you run the risk of damaging that component. And that's, they keep hammering on the consistency.
Right.
It really improves the consistency of it because you remove that variable out of it.
Mm-hmm. Yeah, it sounds like it improves consistency and also the quality.
Correct.
Yeah.
Correct.
We don't make any bad parts.
You're right. No, only good parts. Are there additional challenges to delivering automation here versus other facilities?
I don't think challenge-wise. I will say Atlas has their own automation group. Luke and I are part of that group. We have 2 other fellows, Matt and Cody. We all work together extremely well. Whereas I think maybe some other facilities, they have to bring an integrator in. Hey, here's what we want to do. Here's how we want to do it. Then it's pretty much up to that integrator to figure it out, present them with a solution, see if that's going to work for them. Whereas we're in-house, we know what we want, we know what we need, we know where it's going, we know what part so it's easier, I think, for us to implement something, automate it, and monitor it.
Yeah, I would just add to that the challenge that I see, and Andy can agree with, is where some facilities, their product line is more narrow, where we're very broad. Mm-hmm. So we have a number of different products that run on a number of different machines. Yeah. And that sometimes becomes like, how do we streamline the automation process to accommodate all those different products? Where, for example, some facilities, they have an inline system, mold, center, it's everything's in a line. We have more of a challenge because with the changeovers we have with different products, it's hard to do that. Mm-hmm. So that is one thing that with Atlas, because we accommodate our customers with all the different product lines they ask for, where other facilities, they might say, well, they just do connecting rods, or they just do, and it's easier to set up a process that's just the same every time, where, one of our challenges is because we service our customer with whatever they need. So,
okay.
The other side of that, and on this extend on Andy's point, if another company brings an integrator in, and even if we would bring an integrator in, we weren't the people that touched and developed that, but now you have to maintain it.
Right.
So when something isn't going the way it should, and everything has its wear points in whether it's the gripper hands, whether it's the robot movement, whatever the case may be, there's subtleties to all of that stuff. Now you either have to bring the integrator back in again.
Correct.
Or you have to have somebody in your maintenance group or somebody in your setup operation understand trained in understanding that piece of equipment.
Yeah, so I guess bringing that person back in could force you to shut a line down for a period of time until that person comes in.
And if you want to make an improvement or you want to make a change, we're always looking for ways to improve on what we've done. And it gives us the ability, since we're the ones that designed it, it's a lot easier for us to step in there and make that improvement rather than relying on somebody to say, hey, we want to make a change to this, and there's a cost associated with that too.
Sure.
Well, and a lot of the times when they're integrating something, it affects the speed of a piece of equipment, because if they can't grab it as fast as the equipment can spit it out,
you're going to have a bottleneck somewhere, right?
You're going to have a backup or a bottleneck somewhere. So when they put something in, and I've witnessed this more than one time in the past year or two, where they've installed an initial setup of an automation, only to come back and go, okay, we've got wasted motion here. And the next thing you know, they're back doing an adjustment to that automation movement in order to make that move more quickly and more efficiently.
It's tough to see everything at the initial design until you get it implemented and find out, okay, there's something maybe we didn't quite understand about what we're doing at the initial launch. And so there's always, we always talk about like we're going to need a period of debugging. There's going to be something that okay, we didn't plan on that. There's an unexpected there. So that, I feel like that's what gives us a really good advantage with the team that we have, because we can step in there and say, okay, we can make that change and we can be up and running again.
Yeah.
And
How long is it going to take you to put that under? All 4 weeks.
Yeah.
After day 3, it's like, wow.
Yeah. It's just part of the process.
It is.
I think you guys have both touched on one of the answers, I think, to this next question. But Andy, why don't you talk about some of the advantages automation has introduced to the staff? I know you've both talked safety, and Duke, our safety guy, would be more than happy. He loves to hear that word, safety. But what else?
So we do. We implement a few different robot styles. I know Luke said the 6-axis. We have the industrial grade robot that we have to do some risk assessments on and see. Maybe Luke's 6'2", and if that robot would hit him, it may hit him in the chest. Now I have an operator that's 5'2", and that same robot may hit that operator in the neck or the head area, which is obviously more sensitive than the chest area. So we go through, we'll do a risk assessment, figure out, okay, what speeds are safely. We have to, industrial robot wise, we have to guard this, we have to cage this. We also have a few collaborative robots that will stop upon force, or if it gets hit, it hits a person, it'll stop. We have some scare robots, they're all guarded. So we have to go through, figure out what guardings we need, that safety factor. Our team will go through, do that. Some of the other things that I've noticed, just some of the visualization stuff with lighting, stack lights, indicator lights, beacons.
Communication, gives them communication.
The operators, maybe they're doing something in D cell and they're looking down in C cell. There's an issue down there. There's a problem down there. So some of that stuff, I think, is huge.
I think the mindset sometimes with automation is we're trying to take people's jobs.
Right.
And
that's not it at all.
It doesn't sound like that's the case at all.
Right.
No, we're just trying to help.
The mindset that we are trying to put across is, if you can redeploy a person to do a job that gives them, a more meaningful task using their skill set, because it's tough to put a person at a machine and just have them picking up and putting down all day long. It's tough because
and we've done that.
We have, and
personally we've done that.
I think the turnover rate for something like that is so much higher than when you can take up that person and say, okay, we're going to put you on a job where you're actually, using more of your brain, more of your,
rewarding.
So our goal is with automation, I feel like, is how can we grow as a company and not have to, bring in a lot more people? How can we, use the people that we have and almost assist them in what they're doing with automation? So I feel like as far as personnel goes, that's what our goal is. How can we take a person that may be doing a job that's, it's monotonous, and how can we take that person and put them into a higher skilled position and replace that with a robot who doesn't care if they're picking something up and putting it down, or they don't care if they miss their lunch break, or they don't care. As long as they've got power and air, they're good to go.
Yeah.
So.
I've also noticed with some of the more complex parts nowadays, not just a straight wall bushing, some of the complex parts, to get the speed, to get the rate that you need, you're not going to get there without automating it.
Right.
And
right.
To be cost effective, to provide a good price point to your customer, you have to have that automated. You have to make, 6, 8, 10 parts a minute, 12 parts a minute. And some of the parts we're not going to get there.
And that gives us it keeps us competitive in the marketplace.
Absolutely.
Because we know our competitors are doing that. And if we're going to stay competitive, we have to be able to meet those rates. So,
and not to downplay keeping the people out of the equipment is major for us.
Oh.
We want to keep them away from the moving parts. So all of this has just allowed us to take those intricate parts that, years ago we had a handful of parts that we had to handpick. You've got somebody that's reaching into that press. Granted, it's cycling and it's shutting off, but that doesn't necessarily mean something can't misfire. So any opportunity we have to keep somebody out of equipment, we're all for it. That's a win-win for everybody.
Right. So we kind of talked about the increased quality and some, cost savings and improved cost methods. So let's kind of get into our last question, and I'll throw this to both of you. Like, what are you seeing as future trends in automation?
well, I feel like obviously the more advancements we can get with part delivery, part removal, the more we can keep human hands off of the product, the more successful we're going to be. As far as Atlas goes, obviously our goal would be to how can we streamline, from the molding process to the sintering process to the side, like how can we, eliminate having to stage anything as far as, and there are companies that are doing that. And I feel like that's, some goals we're looking at. Obviously, we're trying to ramp up our automation in our sintering area and our secondary area because we're heavily automated in our molding area, but I know that the goal is to try to implement that through the plant. So
Okay.
Just
Andy?
this week, I was doing some stuff, and I went through and I serialized some of the robots so we can do some, not PM blend, but PM maintenance. And I realized we had 25 robots in our facility. And then I went through and did the same with our cameras. We have 10. So the future, I believe, is 50 robots, 20 cameras.
Right.
As Luke said, our molding department on our bigger tonnage of presses is pretty heavily automated. Next would be our sintering department. And I know Uncle Tom would love that if our sintering department was all fully automated. But with the sintering department, you have to automate getting it on, loading it, and
both
automate
ends of the
unloading
furnace.
it. You have to do both ends, correct?
Yeah.
And then our secondary department is starting to ramp up. We're making huge improvements back there. So
there's been a big push for collaborative robots, and that's basically a robot that can work right next to an employee without any guarding. And I feel like that's a big push in the industry. How can we deploy these robots? Because the speed that they have to travel in order to keep up with the equipment, it creates a danger if a person's working next to them. So there has been a big push for that. And we do have a couple collaborative robots, in our plant right now. So I feel like in the next, 10, 15 years, that's probably going to be more of a push. How can we have these robots working next to people without having to have extensive amount of guarding? So I feel like
they really shine in the machine tending realm, the collaborative side. So that's what we need. That's an immediate need for our secondary department.
And obviously there's going to be more visions, more cameras, more, Now
we're into the AI vision.
Right. Just how can we, and I feel like the more automation can be implemented by person in a quicker fashion, where you can, bring some automation to a piece of equipment and get it going at a quicker, deploy that quicker. I feel like that's the push too. That way you can, move automation around from machine to machine where, right now, a lot of our automation is specific to that machine.
It's pretty dedicated.
Right. So.
And they alluded to the fact that it's a challenge for us because we have quite a bit of turnover. The same part is in a piece of equipment for more than days to weeks,
right?
Not months and months.
Those tools are coming.
Yeah, and those tools are coming back
year-long runners.
No, not very often. So it's one of those things that we have to be cognizant of. That equipment that they're going to put in place needs to be flexible enough,
right,
to account for those kind of changes.
Yeah, good point. Yeah, I've been here now 3 years. I think one of the coolest things is what you guys do. I mean, it's really, when I came here to see the automation we had, I had no idea. And
It's very
really cool
challenging.
back
It's
there.
very rewarding because
It is.
we have to think outside the box a lot.
Yeah.
I mean, there's not a solution sold for what we do a lot of times. We have to sit down together and say, okay, how do we get from point A to point B?
Right.
And we have to, and I'm thankful we have such a great, talented team of people to do that with.
Yeah.
Yeah, I mean, the four of us, you know, I guess Luke and I do a lot with the schools. We go to the local schools and talk to the students, career path, career days. And we always tell them, you know, when you drive down the main drive here and look over at our facility, you would never know there's 25 robots in there, there's 10 cameras in there, there's, you know, artificial intelligence stuff in there. I mean, we're not lack of technology by any means. We're just.
And I feel like Atlas leadership has they have been very supportive and you know, they've been very on board with how can we, you know, bring technology in that's going to make our plant more efficient, safer, and just all around, just, you know, how can we make our production shine with this automation?
Yeah. Well, thank you for watching episode 8 of the PM Blend. Listen, if you haven't toured a PM facility before or would like to see more, I'm telling you, it is really cool what these guys do. Please reach out to us. We'd love to have you in. We'll give you a tour. Joe is the dedicated tour guide, and he's given it a couple times. He'll give you a great tour. And Andy and Luke and their team would be more than happy to have you in. So,
Absolutely.
Thank you again, and please do join our socials.